Good morning, afternoon, or evening, cats and dogs. Today's video comes from the lessons 8.1 and 8.2 guided notes on circles, circumference, and area, with a little bit of perimeter mixed in too. So let's start by talking about what the perimeter of a shape is, as well as what is the area of a shape. The perimeter of a shape is the total distance around the outside of a shape. So if we're talking about fencing in a backyard, if we're talking about a baseboard that you're putting around where the floor and the wall meet in a room, that's going to represent perimeter. When we talk about area of a shape, we're talking about the amount of space inside a shape. So if we're talking about how much fertilizer we need to put in a yard, if we're talking about how much flooring to purchase to put in a room, that's going to represent the area of a shape. So let's begin by talking a little bit about perimeter of rectangles and squares, as well as area of rectangles and squares. This is something you've probably seen in years past, so it's not really new, but it's definitely something that we're going to talk about here. So first things first, let's talk about the perimeter of a rectangle, which again is the distance around the outside. The formulas that we can use are L plus W plus W. And I know that L's look a little bit like ones, but those are L's. They're sort of cursive looking L's. So length plus width plus width. That's probably what you would have used back in elementary school to find the perimeter. The formula that's on the formula sheet that I provided for you is 2L plus 2W. So that's the one with the heart next to it. That's the one we're generally going to use here. And then the last one that you could also use is 2 times the sum of the length and width. So add the length and width together and then multiply by 2. And again, that's for the perimeter of a rectangle. If we're talking about a square, and there's a square right down here below where every side is length S, how would I find the perimeter of that? Well, if you recognize that there's 4 sides, all of length S, just take 4 times S. Now, could you still use 2L plus 2W or L plus W plus W? Absolutely. It's just maybe a little bit easier, a slight bit easier to do 4 times the side length. Let's talk about area of rectangles and squares. Again, the space inside. So for the area of a rectangle, that's length times width. And again, these formulas are on the formula sheet that I provided for you as well. So please make sure you use that and refer to it and see where these formulas are on there as well. For the area of a square, since every side is S and we're doing length times width and both the length and the width are S, we can either do S times S or S to the second power. And while you don't have to memorize these formulas, we're going to see these so many times, you know, it should be pretty easy to utilize in our examples. So let's go ahead and start with some pretty simple examples where we find both the perimeter and area of rectangles or squares that are given. Please recognize that it doesn't matter which dimension is the length, which dimension is the width. You're going to get the same perimeter, you're going to get the same area throughout. So it's not really important which one is which. And again, don't forget that formula sheet that you have. Find those formulas on there. One of the first things I always do, because we have a lot of formulas in this unit, is I always write down the formula that I'm using. So you're going to see that every single time, and I really suggest that you do that as well. So our first rectangle has dimensions 3 inches and 7 inches. So if the perimeter is 2L plus 2W, I let L be 7, excuse me, and W be 3, although again it doesn't matter. So I replace L with 7, I replace W with 3. I did 2 times 7 plus 2 times 3. We do have some blanks to fill in here. 2 times 7 is 14, 2 times 3 is 6. 14 plus 6, of course, gets us a perimeter of 20. Note the label is inches in this case. It's not inches cubed, inches squared, or any of that. It's just inches because we're looking at the distance around the outside. For the area, we're going to do length times width. Again, that's that shaded space inside. So take 3 times 7 or 7 times 3. It gets us an area of 21 inches squared. And again, what does this represent? So we're talking about square inches or inches squared. We're talking about the number of squares that are 1 inch on each side that I can fit inside of this rectangle. So anytime it's perimeter, it's just inches, feet, meters, miles, whatever. If we're talking about area, it's going to be inches squared, feet squared, meters squared, miles squared, and so forth. We want to make sure we put the proper label on our answer. All right, number 2. So I've got dimensions 6 and 9. So we're going to start with the perimeter, which is 2L plus 2W. So let's take 2 times 6. What I did was I replaced, let's highlight this, I replaced L with 6. this guy here. I replaced W with 9. That's this guy here. So I took 2 times 6 plus 2 times 9. Well, you can plug that all into your calculator one step. It's really easy to accidentally replace like the plus sign with multiplication sign. So I like to show another step. 2 times 6 is 12. 2 times 9 is 18. If we add those together, we're going to get a perimeter of 30 meters. Taking a look at our area, that's length times width. And again, I always start by writing my formula here. So I'm going to take 6 times 9 or 9 times 6. Does not matter since multiplication is commutative. My area is going to be 54 meters squared. And again, don't forget those labels, even in your notes, because if you don't put them in your notes, you're probably going to forget to put them on a quiz or a test. All right, let's take a look at question number 3. So for number 3, we have dimensions 3 and 5. So for the perimeter, 2L plus 2W. I replaced L with 3 and W with 5. Again, it doesn't really matter. 2 times 3 is 6. 2 times 5 is 10. 6 plus 10 gets us a perimeter of 16 centimeters. And don't be afraid to pause the video at any point. If you fall behind, there's a lot to jot down here. Area is length times width. So let's take 3 times 5. Area is going to be 15 centimeters squared. In number 4, we're finding the perimeter and area of a square with side length 5 inches. So we can kind of construct a square here, and every side is going to be 5 inches. So we'll label this here. So if I'm going to find the perimeter, I can just do 4s. So take 4 times 5 to get my solution. My perimeter is going to be 20 inches. I could take 2 times 5 plus 2 times 5. That's still going to get me 20 inches. For my area, I'm going to do s squared, so that's 5 to the second power, which is not 10. Keep in mind that is 25. We're taking 5 times 5, and our label will be inches squared. All right, well, naturally, things need to get a little bit more complicated. So in our examples that we're going to see next, we're going to find the missing dimension of each of the following rectangles. So in both 5 and 6, we're looking for the width. We're given in number 5 the perimeter, and in number 6 we're given the area. So since I'm given the perimeter in question number 5, and I know this one is completely done for us, we're going to use the perimeter formula, and it's a rectangle, so we're going to use the perimeter formula for a rectangle, which is all we really have at this point. We'll have a lot of formulas moving through our unit. So P equals 2L plus 2W. I know my length, it's 20 inches, so I'm going to replace L with 20. I know my perimeter is 208, so I'm going to replace P with 208. So I've got 208 equals 2 times 20 plus 2W. Let's simplify. 2 times 20, of course, is going to get us 40. And now at this step, which I'm going to highlight in purple, we just have a two-step equation, which we know how to solve. We've been seeing this for the last several units, and we've been reinforcing this as well. So subtract 40 from both sides, divide by 2. We get that our width is 84 inches. And our label is just inches in this case since it's a dimension. In number 6, we're talking about a rectangle again. This time we're given the area, so we're going to use the area formula for a rectangle, which is length times width. Replace A with 210, since I know the area is 210. We're going to replace L with 10. So I'll highlight that in green here. So we're given the length. So we have 210 equals 10 times W. It's a one-step equation. Just divide both sides by 10. You get that the width is 21. Notice how the label is just meters. Yes, we're talking about area here, but we weren't finding the area. We were finding one of the missing dimensions. So the width is 21 meters. Let's give this a try. In number 7, we're given the area of the rectangle to be 216 feet squared. We know it's a rectangle, so we're going to use the formula A equals L times W. That's the biggest thing, is decide what formula you're going to use. We're given the length. The length is 8, so I'll replace A with 216. I'm going to replace L with 8, so I'll have 216 equals 8 times W. Divide both sides by 8. We get our width of 27 feet. Again, I'm going to work through the work pretty quickly, so pause the video at any time if you need to catch up on writing down or jotting down that work. Number 8, we are given the perimeter of this rectangle, so we need to use the perimeter formula for a rectangle. We're also given the length to be 15 meters. Sometimes we're also given the width. Just for all of these, we're trying to find W. So we're going to use P equals 2L plus 2W, replace P with 55, L with 15. So I have 55 equals 2 times 15 plus 2W. 2 times 15 is 30, and now it's just a two-step equation. We'll subtract 30 from both sides. 55 minus 30 is 25. So we have 25 equals 2W. My last step is to divide by 2. That's going to get us a width of 12.5 meters. The perimeter ones are a little bit more challenging because you have a two-step equation instead of a one-step equation. All right, let's take a look at numbers 9 and 10.
Yeah.
So in number 9, it says the perimeter of a rectangle, is 100 centimeters. We're given its width to be 9 centimeters. We want to find its length.
Goldfish.
Yeah, okay, maybe go ask Daddy. Daddy can get you some goldfish, okay?
Okay.
So it says the perimeter of a rectangle, we know we're going to use the formula P equals 2L plus 2W. We are going to replace W in this case with 9. Sorry about that, although I could use some goldfish. You might hear my stomach growling a few times here. And we're going to replace the perimeter with 100. So we're going to have 100 equals 2L plus 2 times 9. 2 times 9 is going to get us 18. We'll subtract 18 from both sides. That's going to get us 82 equals 2L. You can hear him yelling possibly. Divide both sides by 2, and we're going to get that our length is 41 centimeters. Again, recognize what formula we're using first, plug in what we know, and then solve that equation. All right, number 10, we're talking about the area of a rectangle in this case. So the formula we're going to use is area equals length times width. Again, use those formulas, but you probably have some of these memorized, at least the pretty simple ones. Just know what we're talking about here. It's going to get a little bit more complicated once we start mixing in other shapes. We'll replace A with 319. We're also given the width to be 11. So I'll have 319 equals L times 11. The inverse of multiplying by 11 is to divide by 11. We'll get that our length is going to be 29 kilometers. All right. Naturally, I have some questions for you to try, so go ahead and pause the video, try these two, and when you're ready to check your solutions, start the video again and we'll take a look at your solutions. All right, so number 1, we know we're talking about the area of a rectangle, so I'm going to go ahead and highlight that. That means we're going to use area equals length times width. The area that we are given is 187.55. We're also given the length, so we will replace A with 187.55. We'll replace L with 15.5, and we'll solve for W. Divide both sides by 15.5. You do get a decimal here. That's going to happen sometimes. We get a width of 12.1 meters. Question number 2, we're talking about the perimeter of a rectangle. So we're going to use P equals 2L plus 2W as our formula. And the perimeter that's given is 29.6 inches. And we are also given the length, which is 8.5 inches. So we will replace P with 29.6. We will replace L with 8.5. So we have 2 times 8.5 here, which is going to get us 17. So we have 29.6 equals 17 plus 2W. Again, replacing, simplifying. Go from there. We'll subtract 17 from both sides. That will get us 12.6 equals 2W. Divide both sides by 2, and that's going to get us 6.3 inches for our width. All right, so we've talked a little bit about rectangles, both perimeter and area. Our next shape is circles that we need to talk about. So let me talk first about circles. A circle represents the set of all points in a plane that are the same distance from a given point, which is why when you use a compass to create a circle, you have that pointed part that you usually stick down on the paper, and then wherever your pencil is or your pen or whatever you're using, that's going to be the same distance away from that center point. So it's all the points that are the same distance or equidistant from your given point, which is called the center of the circle. Now, in this picture, we're showing you both the diameter and the radius, or a diameter and a radius of the circle. Note that the diameter goes the entire way across the circle through the center, both endpoints of the diameter are on the circle, and it does have to go through the center. Whereas the radius goes from the center of the circle to a point on the circle. So one endpoint is in the center, the other is actually on the circle itself. It's important to be able to identify those things and also understand the relationship between the diameter and the radius of a circle. I know you've probably talked about chords as well. We're not going to deal with them right here because we're going to be using the circumference and area formulas. But let's talk a little bit about the relationship between the diameter and radius. What do you think their relationship is? So if you're recognizing that the radius is half of the diameter, you are absolutely correct. So since the radius goes from the center to the outer edge, it's only half of the diameter. The other relationship that we have is that the diameter is twice the radius. These are relationships that are pretty important for us to understand. The formulas that we're going to use are going to be involving both the radius and diameter of the circle, specifically the radius on the formulas on the formula sheet, although there is a formula for circumference of a circle that involves the diameter. I do want to mention that circumference is just the perimeter of a circle. So instead of saying the perimeter of a circle, we call it the circumference, the distance around the outside. Before we get into finding both circumference and area of a circle, though, let's identify both the diameter and radius of each of these circles. So looking at our first example, what's given to us? Hopefully you recognize that the radius is given to us. It's 4 meters. Since it goes from the center to the outer edge, what does that make the diameter? If you're thinking 8 meters, you're absolutely correct, because remember the diameter is twice the radius. In the second example, or the middle example here, we're given the radius again. That means the diameter is going to be 16 inches. In our last example, we're actually given the diameter. The radius is half of that, so half of 15 is 7.5. So we're given the diameter of 15 feet. The radius is half of that, which is 7.5 feet. All right, let's move ahead and talk a little bit about circumference and area of circles. So the circumference of a circle is 2 pi r. That is the formula. I'm going to highlight that in yellow that's on your formula sheet. That being said, you could also use pi times the diameter, because pi, which is a Greek symbol, represents an irrational number, is always the relationship of the circumference of any circle to its diameter. And you can look into that a little bit more, like what is pi besides a Greek symbol, besides 3.14159, etc. And we are coming up on Pi Day here next weekend, I think, depending on when you're listening to this video. So we're looking at March 14th. Which was actually the due date for my first child, although he ended up being born on March 13th, go figure. So 3.14159, we'll use the pi key in our calculator. This is something we'll have to show you where to find if you don't know where it is and how to use it, and some of the weird things that sometimes can happen when you use the pi key, depending on your calculator. So we'll address that in class, of course. Most times, though, we're going to use the 2 pi r formula just because it's the one that's given on your formula sheet. But pi times the diameter also works because we can replace 2r with d, since the diameter is twice the radius. The area of a circle, again, this formula is on your formula sheet, also involves the radius. It's pi r squared. We will write our answers in terms of pi as well, which means having pi as part of our answer, and we'll round it to the nearest tenth. The reason why writing an answer in terms of pi is useful is if you're looking for an exact answer instead of a rounded answer. So let's get into our first couple of examples here. So number 11, it asks us to find the circumference and area of each circle, and we'll use calculator pi. So we're going to use the pi key instead of using an estimate of 3.14. We will write our answer in terms of pi, so you can see like a blank and then a pi, and then approximately equal to where we'll round our answer to the nearest tenth. So in number 11, I do just like to identify the diameter and radius first. We're given the diameter of this circle, which is 10, which means the radius is half of that. That is going to be 5. So let's start off by finding, let me see what's, okay. Let's go ahead and start by finding the circumference of the circle, which is 2 pi r. So replace r with 5. We do 2 times pi times 5. Then what I do is I take 2 times 5, and I end up getting my circumference to be 10 pi. That's my answer in terms of pi. And then in my calculator, I just do 10 times pi, which gets me about 31.4 when I round to the nearest tenth. So circumference, you can fill in that blank, equals 10 pi exactly in terms of pi, and that's about 31.4 meters. Since it's a perimeter, our label is meters. For area, we'll do pi times r squared. R in this case is 5. So take pi times 5 squared. 5 squared is 25, so I will write my area as 25 pi, and 25 times pi is about 78.5 when I round to the nearest tenth. So the area is 25 pi, that's about 78.5. Since it's an area, we'll write it as meters squared. All right, in number 12, we are given the diameter again. The radius is half of that, so half of 7 is 3.5. So circumference is 2 pi r, replace r with 3.5. Then I take 2 times 3.5, that gets me 7. So my circumference is 7 pi, which ends up being about 22. Something, by the way, you might notice is, remember that other formula that's not on the formula sheet for the circumference of a circle is pi d, and the diameter is 7, so pi times 7 kind of makes sense. For this one, we had 10 pi, pi times d. And I'll go ahead and reveal that up here. So 7 pi, which is about 22 meters. For the area, we're going to do pi times the radius squared. A lot of this unit is really just identifying the formula we need to use, plugging in your numbers, and then plugging it into the calculator correctly. So definitely practice plugging these into the calculator to make sure you know how to do it. So we're going to take pi times 3.5 squared. If you're having trouble knowing how to square numbers in your calculator, please let me know. We will practice this in class. 3.5 to the second power is 12.25. And then if I take 12.25 times pi, I get about 38.5. Something to stress to you is if you don't know how to square a number in your calculator, don't do 3.5 times 2, but you can do 3.5 times 3.5. So we fill in the blanks here. We get 12.25 pi, or about 38.5 meters squared. All right, let's slide ahead to our next two, and then I think I have some independent practice before we get into a handful of word problems here. So number 13, we're given a radius of 8 centimeters. That means the diameter is 16. Do I really need the diameter for either formula? No, but it's good to practice it. Circumference is 2 pi r, replace r with 8. So we're going to do 2 times pi times 8. Take 2 times 8 to get a circumference of 16 pi, which is about 50.3. Again, we'll put a label of centimeters there since it represents a perimeter. I'm going to work through this pretty quickly at this point because it should be becoming pretty routine. We'll give you a chance to try some on your own too. Area is pi r squared, so we take pi times 8 squared. 8 to the second power is going to get us 64, so the area is 64 pi. Take 64 times pi to get about 201.1 centimeters squared. All right, finally in question number 14, looks like I didn't type this in. The radius is going to be 6 feet since we're given a diameter of 12 feet. I'll type that in here. So when we go to do our circumference, we're going to do 2 pi r. So we're going to take 2 times pi times 6. 2 times 6, of course, is going to get us 12. So we end up with a circumference, let me slide this up a little bit, of 12 pi, which is about 37.7, in this case 37.7 feet. Finally, area, we're going to do pi times the radius squared. The radius is 6, so do pi times 6 squared. 6 squared, or 6 to the second power, is 36, so I get 36 pi, which is about 113.1. Don't forget that label of feet squared. All right, let's give you a chance to try one of these on your own. Go ahead and pause the video. Try this problem, finding both the circumference and area, writing your answer in terms of pi, meaning you have a number times pi, and rounded to the nearest tenth. All right, so let's see how we did here. We're given a radius of 4.5 meters. So for the circumference, we're going to do 2 times pi times r. R is 4.5. 2 times pi times 4.5 is going to get us 9 pi, which is about 28.3 meters. For the area, we're going to take pi times r squared. R is 4.5, so let's take pi times 4.5 squared. 4.5 squared is 20.25, so our answer is 20.25 pi, which is about 63.6 meters squared. All right, let's go ahead and get into some word problems that deal with circles, both circumference and area. So for some of the questions, you're going to notice that I'm going to separate it into 4 different parts. Like, what am I given? What do I know? What am I asked to find? What can I use to solve this? Like, what formula are we going to deal with here? And then, does my answer make sense? It's a good idea to always think about that. We've been stressing that throughout the year, but especially with this stuff, we definitely want to make sure our answer makes sense and is reasonable. So for number 15, it says the circumference of a circle is about 100.53 meters. What is the radius of the circle? So we are given the circumference of a circle. So ding, 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 I'm going to use the circumference formula for a circle, kind of like when we did the perimeter and area questions with rectangles. We are trying to find the radius of the circle. So, and I'm given the circumference, by the way, it's 100.53 meters. Or about that, because we are rounding that. So I'm going to use the circumference formula for a circle, which is 2 pi r. And I'm going to replace c with 100.53. So I have 100.53 equals 2 pi r, or 2 times pi times r. The way I suggest doing this is to divide both sides by 2 first. What that does is it leaves you with pi times r still, but it gets rid of the 2 on the right-hand side. 100.53 divided by 2 is 50.265. And notice I'm not rounding anything. And then now pi is just a number. So I'm going to divide both sides by pi to solve for r. So 50.265 divided by pi. It's not going to give me an exact answer since these numbers are rounded throughout. But if I take 50.265 divided by pi, it gets me 15.999844643. So that's really going to be about 16 for the radius. And in this case, we're talking about meters. So my radius is just going to be 16 meters. You're going to get an answer pretty darn close to 16. The reason why it's not exactly 16 is because this circumference, the 100.53, originally was rounded. Now, number 16, I complicated things a bit. I wrote the circumference in terms of pi, but we're going to treat it the same. Well, pretty similar, I guess I should say. So it says the circumference of a circle is 28 pi inches. What is the radius of the circle? First of all, if you recognize that we're talking about the circumference of a circle, and you're thinking, well, that's pi d, that means that 28 has to be the diameter, that could help you find the radius. But you can also use the circumference formula, which is 2 pi r. You can replace c with 28 pi, which seems weird. You don't need to write it as a decimal. You can leave it as 28 pi. And know that we're trying to find the radius of the circle again. So I'm going to replace c with 28 pi. So I have 28 pi equals 2 pi r. But instead of dividing by 2 first, I actually divided by pi first. And now you could divide by 2 first as well. It would leave you with 14 pi. But if I divide by pi first, it gets rid of the pi on both sides. So if I take 28 pi divided by pi, it leaves me with 28. So I get 28 equals 2r. Divide both sides by 2, that's going to get us a radius of 14. So in this case, it'll be 14 inches. There are other ways to approach these as well. Again, like I said, if you know that the circumference is pi times the diameter, then you know that 28 is the diameter and the radius is half the diameter, so it's 14. You could have divided by 2 first and then divided by pi. There is a way to divide by both 2 and pi at the same time. You just have to do, if you do 28 pi divided by 2 pi, you have to put the 2 pi in parentheses. And we'll practice some of those things in class as well, but we're just giving you kind of the shortened version here in what's already a pretty lengthy video. All right, I did give you one of these to try, so go ahead and pause the video, give this problem a try, and when you're ready, start the video, we'll take a look at it. All right, so once again, we're talking about the circumference of a circle, so we're going to use c equals 2 pi r. Replace c with the 78.5398. So 78.5398 equals 2 pi r. I divided both sides by 2 to get 39.2699 equals pi r. I took 39.2699 divided by pi. When I did that, I'm going to go ahead and plug it in again. I ended up getting 12.499974, which is about 12.5. So I would say that my radius is about 12.5 meters in this case. All right, let's get into some word problems. So number 17, it says a carousel has a diameter of 40 feet. How far does the carousel travel in 12 revolutions? So I always want to start by thinking, what am I given in this case? Well, we know that we're talking about the diameter of this carousel to be 40 feet. So we're given the diameter of this thing. We also know that this is a round or circular shape. So you've seen carousels in Hershey Park probably, or maybe some other amusement parks, or even just some regular parks in and of themselves. But we also know we're talking about a carousel here. So that's a round or circular shape. Plus we're given the diameter. So even if you're like, I don't know what a carousel is, we're given the diameter of this thing, which tells us it's a circle. What am I asked to find? Well, we're specifically asked to find how far the carousel travels in 12 revolutions, or 12 times around. So that's given in the question. What that represents is, if we're talking about how far around, like around the outside, the circumference times 12. So we're going to find the circumference and then multiply by 12 since we're doing 12 times around. One time around the carousel would be one circumference. 12 times around would be the circumference times 12. So that means we want to use the circumference formula for a circle, which is 2 pi r. Keep in mind I'm given the diameter to be 40 feet, so I want to use the radius, which is 20. So I'll do 2 times pi times 20, which gets me 40 pi for the circumference. And that represents one revolution, or one time around. And I want to find 12 revolutions, so I'm going to multiply by 12. So you can see that I did that here. Let me erase that box. I took 40 pi times 12, which got me 480 pi. I did round to the nearest foot. It ends up being like 1,507.98 or something. So it rounds to about 1,508 feet in 12 revolutions. At the end, I always like to think, you don't have to write anything out, but like, does my answer make sense? So if you get something that's like absurdly high, like 20,000 feet, you might be like, okay, that seems way too high. That's like 4 miles or something. If you get something that's really low, like let's say you just get like 10 feet, hopefully you realize 12 times around a carousel is going to be more than like 10 or 12 feet or something like that. So you can't always answer that question and know for sure your answer is correct, but you at least have a decent idea of whether or not your answer makes sense, and you should always think about that. All right, taking a look at question number 18, let's read what this question says. A merry-go-round has a radius of 4.5 feet. How far does a rider on the edge of the merry-go-round travel in 20 spins? So this is a lot like our last question. A merry-go-round is round. It looks like a circle, of course. So we need to think about whether we're talking about the circumference or area. But like the last question, if we're riding on the edge of the merry-go-round, we're talking about circumference because we're looking at the distance around the outside of a merry-go-round. So when we talk about circumference, the formula that we're going to use is 2 pi r. Now keep in mind, on your formula sheet, you'll see this formula, and it looks like the 2 and the pi and the r are just kind of squished together. So it sort of looks like a really weird symbol, but that just means 2 times pi, which is just the symbol we use for 3.14, etc., times the radius. Now we're told what the radius is in the problem. It says that the radius is 4.5 feet, so you can see I identified that here. And I did 2 times pi times the radius of 4.5. Now I plugged this into my calculator. 2 times pi times 4.5 gets me around 28.274 feet. And that's for one time around the merry-go-round. So that's how far we would travel in one spin or one revolution of the merry-go-round. Now, you're going to notice that I put the ... here that represents that this keeps going. So I've got this answer in my calculator. I don't have to write every single digit that's in the calculator, but I don't really want to round it when I do my next step. So I'm going to use this exact answer. And since we're going 20 times around on the merry-go-round, which Mrs. Garcia would not do, or she would not be faring very well, but we would take that answer that's in our calculator, the exact answer, 28.274,
etc., and multiply that by 20. If we take a rounded answer, let's say like 28.3 times 20, we're going to get a slightly different answer. It's not very different. We end up getting about 566 feet instead of 565.5 feet, but we want to be as precise as possible. That's why we have our calculators. So again, for a problem like this, we find the circumference because we're looking at the distance around the outside, and then we're going to multiply by 20 since we're going around that Ferris wheel in or carousel in our last question 12 times. In this question, we're going around 20 times, so we're going to multiply by 20. We'll also see some similar questions. We saw a carousel question. We've got a merry-go-round question. We're also going to see probably a Ferris wheel question before all is said and done. But again, the same idea. Find that circumference, multiply by the number of times that you're going to go around that object, whether it's a Ferris wheel, merry-go-round, or a carousel.
Right, so number 19. If only get a little bit longer, I know this video is getting kind of long. Hopefully you're not watching all of it at once, but let's talk about number 19. A section of a basketball court is shown below. The circumference of the circle that contains the free throw line is about 358.14 inches. What is the distance between the free throw line and the three-point arc? And that's what the question mark, that line represents in the picture. So what are we given? Well, we know this is a circle that we're dealing with, but we're specifically given that the circumference of the circle is 358.14, which tells me, by the way, that I'm probably going to be using c equals 2 pi r as my formula. I'm asked to find, and I'm going to highlight this in blue, the distance between the free throw line and the three-point arc, this distance right here. And so that's going to be from the center of a circle. The way that we're specifically laying this out is from the center of a circle to the outer edge, which once again is going to represent the radius of the circle. So we've got our formula, c equals 2 pi r. We need to find the radius. Replace c with what we know it is, which is 358.14. Divide both sides by 2. I like to divide by 2 first because when I divide by pi, it gets me a nasty decimal, so it's better to just divide by 2 first. I get 179.07 equals pi r. Now I divide both sides by pi, and 179.07, I'm going to plug it in to my calculator divided by pi, gets me 56.99975,132. So that's going to be about 57, which means we're looking at about 57 inches. And while I'm clearly at like 4'10", not a basketball player, we do want to think, does our answer make sense? 57 inches is a little bit less than 5 feet. That kind of makes sense if we're looking from the free throw line. We're looking from the free throw line to the outer edge. Again, depending on which size basketball court you're looking at, I think sometimes different age brackets or age groups, they might be different sizes, kind of the way with soccer fields sometimes, and baseball fields change. But we're looking at a distance of 57 inches. Kind of makes sense. Again, I'm not a basketball expert by any means, but if we're looking at like, I don't know, 100 inches or something, that's going to be way too high. If you're looking at just 12 inches, I know that that's definitely way too small. All right, so the other thing that we have here, and I'm going to go ahead and flip to the last page, is we do have some questions that involve scale with finding area of circles. So in number 21, it says, what is the area of the circle below in square feet? We are going to write our answer in terms of pi. I'll also round to the nearest tenth as well. So here's the deal. If we know that 1 inch represents 4 feet and the radius of this circle is 5 inches, what I would do is convert your 5 inches into 20 feet. Let me delete that. Since our radius is 5 inches, what I'm going to do is multiply 5 by 4 to figure out what that is in terms of feet. That's going to get me 20 feet. 1 inch represents 4 feet, so 5 inches represents 20 feet. So I'm going to use a radius of 20 feet since I want my answer in terms of square feet. So the area formula for a circle is pi r squared. Excuse me. So we're going to do pi times the radius, which is 20 squared. 20 squared gets me 400, so my answer is going to be 400 pi. Sorry about that. It was freezing for a moment. My area is going to be 400 pi. That's going to be about 1,256.6 feet squared. I did round to the nearest tenth. It did ask for our answer in terms of pi, so either one of these is fine. Now, I often have students who think, well, if I take area equals pi r squared and I want to use 5 as my radius, can I do that? Sure, pi times 5 squared gets me 25 pi, and then they say, can I just multiply by 4 at the end? Take a look at that. If I take 25 pi times 4, that gets me 100 pi, not 400 pi. So here's the thing that you have to realize is that 1 square inch doesn't represent 4 square feet. So yes, 1 inch represents 4 feet, but 1 square inch doesn't represent 4 square feet. So what is true is that 1 square inch represents 16 square feet. So you actually take 4 to the second power to get 16. If you take your 25 pi times 16, that will get you 400 pi. I don't recommend doing it that way. I recommend converting into feet first and then finding your solution, but it can work. But you'd have to recognize that 1 square inch represents 16 square feet. You have to square the 4. All right, let's give number 22 a try. What is the area of the circle below in square feet? Write your answer in terms of pi. So the radius is 7 inches. I multiplied by 12 since 1 inch represents 12 feet to get 84 feet for my radius. So pi r squared is going to be pi times 84 squared, which is a pretty big number. 84 squared is 7,056. So I get an answer of 7,056 pi, or about 22,167.1 feet squared. Now, again, if you want to start by using just inches and do pi times 7 squared, that's going to be 49 pi. But then you need to multiply by what 1 square inch represents, which is 144 square feet. So if you take 49 pi times 144, you are going to get that 7,056 pi. So I wouldn't recommend doing it that way, but it can work. All right, the last thing that we're going to talk about here is semicircles, which are half circles. We're going to see this in our composite figures lesson that we're going to be working with. So to find the area of a semicircle, since it's a half circle, you can find the area of a whole circle and divide by 2. You can do a half pi r squared, you can do 0.5 pi r squared, or again, you can just do pi r squared and just remember to divide by 2 since a semicircle is half of a circle. So number 23, let's take a look at this. We're given the diameter of the circle since it goes the whole way across the circle, not just from the center to the outer edge. If the diameter is 12, the radius is 6. So I can use half pi r squared or 0.5 pi r squared. I like the 0.5 pi r squared, so I took 0.5 times pi times 6 squared. 6 squared is 36. I then did 36 times a half, or 36 times 0.5, which is 18 pi. So I end up getting a solution of 18 pi. That is about 56.5 feet squared. Again, you could do pi times 6 squared, get an answer, divide by 2. So that would get you 36 pi. Divided by 2 is 18 pi, which again, about 56.5 feet squared. Number 24, we're given a diameter of 6, which means the radius is 3. So let's plug it in. We're going to do 0.5 times pi times 3 squared. 3 squared is 9, and half of 9 is 4.5. So we get 4.5 pi, which is about 14.1 meters squared. Notice the difference in both 25 and 26. We are given the radius, not the diameter, since we're going from the center to the outer edge. So half pi r squared again, just write those formulas down. That's going to be 0.5 times pi times 4 squared. 4 squared is 16, and half of 16 is 8. So I get 8 pi, which is about 25.1 inches squared. And finally, number 26, because this is already a very long video, we've got our radius of 7. So we're going to take half times pi times r squared. R is going to be 7. So 0.5 times pi times 7 squared. 7 squared is 49. Half of 49 is 24.5. So we get an answer of 24.5 pi, which is about 77 millimeters squared. So I went through those pretty quickly, but it's something we are going to practice a little bit more as well. when we talk about our next lesson. I do want to point out also, although I'm not going to take a lot of time to go through it, there is a summary at the bottom of that page that just kind of summarizes area, perimeter, and circumference for you and what labels we use on those. So that's not something that's a bad idea for you to go back and review prior to a quiz or a test. It would not be a bad idea to do that. So take some time and look over that chart and refer to it as needed. Thanks for listening.